Not every quadrilateral can be inscribed in a circle, but for those that can, the product of the lengths of these two opposite sides plus the product of the lengths of these two opposite sides is equal to the product of the lengths of the two diagonals. This equation is called Ptolemy's theorem, and it can be interpreted geometrically in terms of areas of rectangles. The equation is true no matter where the vertices lie on the circle. Now let's see why Ptolemy's theorem is true. These two angles are equal because they cut off the same chord. Rotate this triangle until this diagonal of length E lies along this edge of length B. The two shaded triangles are similar. Likewise, these two angles are equal because they cut off the same chord. So rotating this triangle reveals another pair of similar triangles. If we rotate both triangles, we see that they join along a common side that divides this diagonal of length F into two pieces of lengths X and Y. Now we have two pairs of similar triangles, so ratios of these corresponding sides are equal. And ratios of these corresponding sides are equal. And the rest is just a little algebra. The final result is Ptolemy's theorem on quadrilaterals inscribed in a circle.